Okay? What's the relationship? Well, I have gamma 1 is equal to 1 over square root of 1 minus v1 squared over c squared. So if I square both sides, gamma 1 squared, I have 1 over 1 minus v1 squared over c squared, right? And I could bring this up to there. 1 minus v1 squared over c squared is equal to 1 over gamma 1 squared. So essentially I'm like resolving it and in terms of v1. So then this one goes over there. 1 minus 1 over gamma 1 squared. Simplify it. We can say gamma 1 squared minus 1 over gamma 1 squared. Okay? So get it under a common denominator. Gamma 1 squared minus 1 over gamma 1 squared times c squared equal v1 squared, and then square root both sides. So square root this, square root this, square root this, and then if you square root the bottom, you get rid of it. So in terms of gamma 1, v1 is what? v1 is square root of gamma 1 squared minus 1 times c over gamma 1. So this could be a general relationship that you can remember. If you know the gamma and you're trying to go backwards and solving the v, v is equal to square root of gamma squared minus 1 over gamma times c. Okay? So if the speed is exactly 0, gamma 1, if you put gamma 1, you're basically going to get 0 here, so the velocity is going to be 0, right? So you can work backwards from the gamma to get the v. So now I'm going to substitute that into here. But you see what ends up happening is you're going to end up having this square root gamma 1 squared minus 1 over here over gamma 1, and then over here, then you're going to have to substitute what gamma 1 was from the beginning. So the better way to do it, see, oftentimes when you're doing problems like this, you find one way, you see that it might be too long, you backtrack and you say there might be a better way. So the better way to do this is this. Before even substituting this into the gamma 1, what you want to do is put v1 here into here, and you want to get rid of any reference to v. So you want to have here 2722.572c, 1080 gamma 2. So v2, I can use this equation that I derived, square root of gamma 2 squared minus 1 over gamma 2 times c, right? And then minus 720 gamma 1, and then v1, replace it with this equation, square root of gamma 1 squared minus 1 over gamma 1 times c. Now notice what happens. C cancels, C cancels, C cancels, looks much better. Gamma 2 cancels, gamma 2 cancels, gamma 1 cancels, gamma 1 cancels. And I have an equation that looks much better now. 2722.572 is equal to 1080 square root of gamma 2 squared minus 1 minus 720 square root of gamma 1 squared minus 1. Okay, now from the bottom equation, I can substitute what gamma 1 was in terms of gamma 2. Remember, gamma 1 was 3540 minus 1080 gamma 2 over 720. So replace that with this gamma 1 right here. So you're basically going to square that thing. So I'm going to take the gamma 1 squared here. I'll have a huge equation. And I'll have 3540 minus 1080 gamma 2 quantity squared over 720 quantity squared minus 1, right? So I'm basically applying this equation. I'm squaring the whole thing, and then I'm subtracting, and then I'm also squaring the bottom, and then I'm subtracting it from it 1. But one of the things you can do is take the 720, bring it in the radical as a 720 squared. 720 squared. And then when you distribute that, you'll get rid of this. Okay, so the summary will be what? Now, what you're going to be able to do, the best you can do probably, you can expand this out a little bit and simplify it. So we can do the first quantity squared, 3540 squared, and then subtract from it 720 squared. Okay, and you get a huge number times 1080 times 2. So double the product of the two. You have 7646400 gamma 2 positive, and then you square the last term. 1080. This all radical, gamma 2, and then this whole radical, and then that must be equal to this. Okay? Okay, so now what we were able to do is at least have one equation, and then there's only one unknown variable in there, gamma 2. Gamma 2, gamma 2 squared. Then you have radical, and you have radical. The rest of this is we could be done algebraically. I could put this over here, I could square both sides, or we can put it into solver, into the TI solver, put it all into the solver, and let's see what the solution comes out. So what I'm going to do is use the solver on my TI. When you put this all in, the calculator actually says false, no solution. Okay, so what does that mean? Okay, so what does that mean? It says false. There's no solution to this equation. So it could mean basically our setup is wrong, or maybe one of our assumptions was wrong. Okay, remember what happened. We assumed that the sigma particle was going forward and it disintegrated. The neutron went forward, the pion went backwards, right? Neutron went forward and the pion went backwards. And the sigma was going forward. Could it be possible that maybe based on the number that was given to you here, the initial energy of the sigma, that both of them have to be going forward? So the particle can be going forward, disintegrate, and both the neutron and the pion both go forward. And again, their momentum and kinetic energy is conserved. And so that is very likely. So what would change here? Well, it turns out that not a lot of things will change. As a matter of fact, just one thing. This one changes to a positive. This one still stays positive. This one still becomes minus. So if you follow through, basically here, instead of minus 720, it changes to a plus. This changes to a plus. This changes to a plus. This changes to a plus. When you're putting this equation into the calculator, you don't necessarily have to put in these big numbers. You could put in this equation too, as is. It's actually nicer and neater instead of having to put in these huge numbers. 2722.572 is 1080 square root of x squared minus 1 plus square root of 3540 minus 1080 x quantity squared minus 720 squared. Okay, so let's try that. Two possible answers. Gamma 2 is equal to 1.09239. The possible answer is gamma 2 is equal to 2.60029. Then you take those gamma 2, you put it into here, and you calculate the corresponding gamma 1. That one comes out to be 3.27808. And then the other corresponding gamma 1 for this turns out to be 1.01623. Okay? Basically, gamma 2 is corresponds to the velocity of the neutron, and the gamma 1 corresponds to the velocity of the pion. The pion is the lighter one. So the answer that makes more sense here is that the lighter one, the lighter particle pion, should be traveling faster. The gamma 1 should be 3.27, gamma 2 should be 1.09. It shouldn't be traveling slower than the neutron. So we reject this answer. The answer that we accept is gamma 2 is 1.0923 and 3.27808. Based on that, we can now calculate the final answers. Comes out to be 0.09239 times 1080 mega electron volts over c squared times c squared, c squared, c squared cancel. When you do that, the kinetic energy of the neutron comes out to be 99.78 mega electron volts. Okay? Then if you want to calculate the total energy of the neutron after the collision, you add its rest energy to that. So 1080 plus 99.78, you get 1179.78 mega electron volts. And then the momentum of the neutron, square root of the total energy squared minus the rest energy squared. So you take this squared minus its rest energy 1080 squared, square root that. And when you calculate that, you can do that yourself, and you can calculate 474.848. Okay? And that's in units of mega electron volts per C. Okay? So then what would the kinetic energy, the total energy, and the momentum of the pion be? Well, we're going to use this gamma 808 minus 1 times the mass of the pion, 720 c squared. And then you do this mega electron volts over c squared will cancel c squared. And then you're going to get 2.27808 times 720. Kinetic energy of the pion, 1640.218, and that's mega electron volts. If you add that kinetic energy, 1640 to 99, that's going to come out to be 1740. The total sum of the kinetic energy, 1740 mega electron volts. Remember, that's what the initial kinetic energy of the incoming sigma particle was. So kinetic energy is conserved. Okay, how about the total energy? Total energy of the pion. On top of that answer, add the rest energy, 720. So you get 2360.218 mega electron volts. And then the momentum of the pion, again you do square root of the energy of the pion squared minus the rest energy squared. So 2360 squared minus the rest energy, 720 squared, and then square root of that, and you're going to get the momentum of the pion, 2247.72 mega electron volts over C. Okay? If you add the momentum of the pion to the momentum of the neutron, so 2247.72 added to 474.848, you will get 2722. So the total momentum pion plus the total momentum neutron, 2722. And remember, that was the original momentum of the incoming sigma, 2722. So quite a bit of calculations, a lot of things to keep track of, and it's pretty different than the regular elastic collision type problem in mechanics, okay?